Hey guys, welcome to another video. So today, another video in the nice question series that we've been doing. Today, the question is from the 3-unit extension 1 syllabus, projectile motion, possibly the hardest topic in the syllabus for extension 1. A nice question today from Sydney Grammar 2015. If you haven't already done so, please subscribe to the channel, tell your friends and like the videos, and let's get started. So this question from Sydney Grammar looks like this. So let's see, scroll over here. All right, so we have a projectile being fired up with an initial height of h, right? Let's see what else in the question. I don't think there's anything in the paragraph here that's different to the diagram. So it's fired and it looks like it's traveled a range of r, right, from the origin. And they even give you in the question the equations of motion as well for displacement. Beautiful, right? Nothing fancy there. Gravity is there. Okay, cool. R, horizontal range. Okay, nothing. So sometimes, or I guess the danger is that they put things in the paragraph that isn't in the diagram. So in this case, diagram same as the paragraph. Great. Let's move on. Right? And just to be clear, for those that aren't too familiar with these formulas, see that h there. Initial height there is given. Great, right? We can work with it. Part 1, show that the Cartesian is that easy, nothing fancy about that. And then look at this, guys. 2, 2, 2, 2, 2. That's a 10-mark question in a 70-mark test. That's more than what, I don't know, it's about 14, 15% of the test, one question. If you couldn't do this, if you can't do this, you're stuffed, right? So make sure projectiles is studied leading into your trials. If it's in your trials, it's definitely in the HSC, right? All right. So question 1 is textbook. Question 2, 3, 4, 5. Okay. Let's work through it as we're gonna. Let's do question number 1 first. Cartesian, simple, straightforward. I think. Let's get cracking, right? So I have x equals to v cos theta t, and I have y equals to h plus. I'm just copy and pasting, right? So copying that guy there, minus a half gt squared. All right. So to go Cartesian, we basically make the parametric, the parameter, the subject. So in this case, make t the subject and then sub it into the other one. So t equals to x over v cos theta. And then guys, just plug this into all the values of t there and there. So therefore, y equals to h plus v sine theta times x on v cos theta minus a half. Now I don't have space. Scroll over a bit. Perfect. Half g x over v cos theta squared. Yeah, and then a little bit of simplification there. The v's cancel out, right? And just remember cos squared on the bottom, that's sec squared, right? So therefore, equals to, now, did they want me to put, yeah, that one, put h first, h plus sine on cos is tan. So then that becomes x tan theta minus, now, in this case, gx squared's on top over 2v squared on the bottom. And then cos squared's on the bottom as well. I'm just gonna, guys, let's just get to it. So sec squared. Right? Okay, therefore, that's my Cartesian equation. Yeah, 2 marks. I mean, that is quite generous. Very textbook. Nothing hard about that. Hopefully, if you studied projectiles, nothing hard about that. It's just very, very common. Part 2. All right, let's get there. Part 2, show that r squared. So r is over here, right? So the moment r hits the floor over here, yeah, what do we know? So that point there, right, y equals 0, right? And x equals to r. So it feels like that's the information that I need to sub into the Cartesian, right? They made me do Cartesian, probably going to use it. Now they gave me a coordinate, right? Y equals 0, x equals to r. Let's sub it in, and it looks like I'm making everything, put everything on one side. So let's do so, right? So guys, sub x equals to r and y equals to 0 in, right? To the Cartesian. So that's 0 equals to h plus r tan theta. Let me just have a quick look. Why is it so nasty? Oh, it's because they just times it all by, okay, I still have g under them. So they basically times it all by 2v squared and divide by g. Okay, cool. Minus that on that sec squared. Now, so what I was going through in my head just then is, why does this guy look different to what I have? And I looked at what they had in the denominator. They have g. Right now, I got 2v squared. So it feels like I'm going to times everything by 2v squared and then divide everything by g, and I hopefully will get it, right? So next step, so why don't we times everything by 2v squared? Right, I'll put the 0 on the other end. And wait, sorry, what term comes to r sec? So I'll move everything over to the other side as well. So move everything to the other side and times everything by 2v squared, I get g x squared sec squared minus, right, because I'm moving this guy over, 2v squared r, or maybe they put r first. Let me have a quick look. Yep, 2r v squared tan, and then minus h v squared 2, yeah, equals 0. All right, that's just multiplying everything by this guy, and now let's divide everything by g. I think it works. Let's see, 2, yeah, okay, piece of cake. And then divide everything by g as the next step, right? So then divide that guy by g, you get x squared sec squared. Divide that by g, 2r, and they sort of put like v squared on g like this, 10, yeah. And then this guy divided by g, so you get like 2h v squared on g. That equals 0. Therefore, done. So that was just algebra manipulation of that. And now the next one, what the hell's going on here? Show that r squared equals to that. Okay, am I missing r squared? Oh, the first one's not x squared, it's r squared. Got to sub in r squared on this side, so let's do that. Clean that up. Got to do that and that and that. That's r, right? R. Okay, cool. Let's have a quick look. Now, I've got r squared equals to that. Okay, feels like I'm doing some further algebraic manipulation, right? Okay, whenever I get my students to look at questions like this, right? Always ask yourself, is there anything in the thing you're proving is there anything in this formula here that's no longer in the thing you're proving, because you got to get rid of it? First thing I can see is sec squared's gone, right? There's no sec squared, it's just tan. So why don't we replace sec squared with the identity of tan squared plus 1 and see where that takes me, and then try to make r squared the subject. I think that's the play here, right? And it feels like that they've completed the square somehow. Yeah. How about this? This is what I'll do. I'm going to go a big brain on this, right? Right. I'm going to show you something, right? I'm going to show you something. For part 3, I'm going to explore. I'm going to use the answer and see where it takes me, right? I'm going to expand everything and see if it gets me to something that I know, right? So I said this to my students. I call this the dark side, right, of doing questions where you start from the proof, yeah, and you basically work to something that's true. Now, some teachers give you full marks for it. Some teachers take marks off because we're starting with the question you're not supposed to, but this is what you do, right? Let's expand everything, right? If I expanded everything, just to explore, right? Just explore, and then I'll do it the correct way in a sec, right? Perfect square, so squared, tan squared, theta, minus 2 times that, what's that? 2r v squared on g, tan. Okay, everything's sort of coming up, right? G squared. Yeah, because then look at this, guys. Oh, that's a plus, by the way. Look at this. This guy cancels out. And I sort of have everything I need, right? Because look at this. I got r squared. Sorry, I'll do it in blue just to show. R squared plus r squared tan squared. That's this guy, right? Because when I expand it to 1 plus tan squared, that's this guy. And then I got positive, also when I bring it over to the left, this guy here looks like that. And this guy here looks like that. So this is the game plan. If I can see it now, I can prove that equals to that above. But if your teacher doesn't like that, I'm going to start with this answer over here and then expand it and then move it over and complete the square to make it look right? Yeah, so check this out. This is a bit of a hack. I'm going to move this to the other page just to show you how I'm going to play this out. So I'm going to park this working out here. I'm going to delete it in a sec, right? But I'm going to start with what I know from part 2, right? I'll start with this guy, right? So this is how I ask my students to do it, right? So let's get rid of this first. Yep. Number 3. So let's get rid of the highlights here. Yeah. Actually, I'll leave that one highlighted. Now, I know this guy is 1 plus tan squared, right? As an identity. Yeah. That's r squared there minus 2r v squared on g tan theta minus 2h v squared on g equals 0, right? Now, I can see upstairs, if I expanded this, if I just rainbow this, right? I get r squared, and I'm gonna throw everything else over the fence, right? So I get r squared equals to, throw this guy over the fence, and I get minus r tan, also r squared tan squared. This guy becomes a positive. 2r v squared on g tan theta. This guy becomes positive as well. Yeah, so that looks like the pink term is there, the blue term is there, and the green term is there. Now, so for the blue and the green, I'm going to add, I'm going to highlight this. I'll just add yellow, right? Add yellow and add yellow to both sides to complete the square, right? Yeah, add yellow and yellow, both sides to complete the square. So this is what I'm going to do. I'm going to, for these two, I'm going to add v4 on g squared. And for this guy, add v4 on g squared, right? Because I know, right? I can see it upstairs. This guy here gives me a perfect square, right? Of, was it upstairs? R10. Plus, is it minus? R10 minus v squared on g squared. And then plus the yellow and the pink, so v4 g squared plus 2hv squared on g, therefore, and then I've done it, right? Oops. Yeah, therefore I've done it. All because I knew exactly where to go because I did it upstairs, right? So I guess what I'm trying to say to you is sometimes the questions they give you, use the answer and almost back solve it, right? Yeah, so then you delete that and your answer looks amazing, right? To your teacher. Do you know what I mean? Like that's what you do, right? Just be a bit smart especially when it's projectiles and they give you the thing you have to prove. All right, that was question 3, probably the hardest part. Deduce that the maximum range, max range, is that. Yeah, that's the maximum range. Oh, give me a second. I needed a negative there. Right. You know what? Can I ask a favor? Let's write that as therefore r squared. Write it like the way they told you to write it, right? Bracket there. v4 on g squared plus 2hv squared on g minus r tan theta minus v squared on g, right? Just because for the next part, I think it's actually useful to have it in that form. Yeah? Let's get rid of that box. All right, done. Part 4. Show that, or deduce that the maximum range is that guy. Now, this is how I'm going to do it. Yeah, this is how I'm going to do it. If I'm talking about maximum range, right? Yeah. you know how like this is r squared? And r squared right now, sorry, this is r squared, right? And see how like, if I take something and I subtract something else, right? Then the maximum this guy can be is when this guy is 0, right? So when this guy is 0, I get the maximum, and the maximum is this. Does that make sense? So this guy's the max. So let me say that again. If I take something and I minus another thing, then the maximum that statement can be is when the thing I'm minusing is 0. And when that's 0, so you can say, therefore, right, as like a two-step sort of process, right? Part 4, max range, yeah, is when r squared equals to this guy only. Right? When the secondary part, the bit that I'm subtracting, is 0. Yeah, I don't need brackets there. Right? When r squared equals to that, and then if I square root it, I think I have just enough space. R equals to the square root of this. And then they basically force factorize a g out from the bottom, and it becomes square root of v4 plus, and then they put a square there, and almost like a g there, right? And it becomes like 2. Oh, I got no more space. Sorry. You just do this. And then they did 2h v squared g. Perfect. And that is my max range. So it feels like a bit of a hack. It feels like you have to do differentiation and do calculus stuff. You don't. If the expression is something minus something squared, that something squared is always positive. So if that squared thing was 0, then I have my maximum range. Now, and that theory is also used for the next part. Show that the angle of elevation satisfies that, where R1 is the maximum. So when is the maximum range? Show that tan theta is that. So we've used this part to do part 4. We're now going to use this part to do part 5. Right? That's what it's asking for, right? So let me borrow this statement, and I'll put it as part 5 over here, right? So part 5, borrow this statement, park it up here. Let's start there, right? So in part 5, we're not going to use our part. We're going to use the fact that for R1, this guy has to equal to 0, right? So for maximum range, this guy has to equal to 0. And then what did they ask me to do? Make tan the subject, is it? Show that tan, yeah, perfect. So then for R1, the moment this becomes R maximum range, that's R1. And then if I make tan theta the subject, therefore tan theta equals to v squared on G or R1G. That's it, right? That's all they want. It's one marker, right? Yeah, piece of cake. So let's say that again. When you have maximum range, this guy's 0. If that's 0, then I sub it. I solve that equal to 0 and then make tan theta the subject, and I got it. Last part. Show that tan 2 theta equals to that. Okay, cool. Now, let's see. So I'm gonna put all the things that I have together, right, and try to do this part. So what do I know? I've got an expression for R1. R1 is the maximum range. From this part, that's this guy down here, right? That's part 4, question 4, right? So let me see. So I've got this guy is my R1. And I got H, and I got tan theta equal to this. I've got 2 things, right? I've got 2 things working for me. So let me highlight that again. I've got this guy here, that's R1. And I've got this guy here, Like I said, I mean, feels like I've got all the tools to sub in and hopefully it simplifies. Let's hope it's just algebra, right? So let's see, tan 2 theta, right? Now we know that the double angle for tan is what? 2 tan over 1 minus tan squared, right? So 2 tan would be 2 of these guys, GR1, all over 1 minus V squared over GR1 squared. Oh man, that looks so ugly. All right, so let's see. So that becomes 2V squared. I'm just going to simplify here. G1, and I'm going to common denominator at the bottom. G squared R1 squared minus V squared all over G squared R1 squared. Now, this guy goes away with the squares, and you sort of have like, this guy comes upstairs to be 2G V squared R1 all over G squared R1 squared minus V squared. Okay, cool. That is what tan 2 theta is. Now, right now, that guy there doesn't really look like that guy there yet, right? So it feels like I can use this guy maybe to sub into maybe the bottom. So sub that guy into there, right? Let's see where that takes me, right? So let's go over here, equals to 2G V squared R1 all over G squared. Now, if I square that, right? If I square that, I get 1 on G squared, good, because that cancels out G squared, times V4. Oh, perfect. Look at that, V4. V4? Is it perfect? Let's have a look. V4 plus 2HV squared G minus V squared. Let's have a look. That becomes 2G V squared R1. Now, on the bottom here, G squared goes away. And on the top, I can factorize V squared out, but now I was expecting this guy to cancel out, but let me see. If I square that, it should be fine. Should be fine. Let's have a look. That becomes, sorry, if I square that, it becomes V4. I'm missing a V. I'm missing a V squared. Oh, V, perfect. Oh, okay, cool. That should be V4. Good, good, good. I was like, it's not canceling out. That's a problem. Okay, cool. And then this guy goes away with this guy. Ah, yes, cooking. We're cooking. We're cooking. V squared G. And then last but not least, 2G, 2G, V squared, V squared. Haha, got it. Equals to R1 on H. Tan 2 theta equals 2. Yeah. So this question, I think it's less, there's projectiles in there. There's the concept of maximum range, but it's a lot of algebra, all right? That's what makes this question quite difficult. 10 marks, 3-unit paper, 70 marks in total. Hopefully that was a nice question, guys. I'll see you at the next video. Like the video if you can. Subscribe to the channel if you haven't. See you guys later.